Okay, so today what we're going to be looking at is something, mainly we're going to look at minimum spanning trees. So first of all, we're going to look at what is a tree. So a tree is a connected graph that contains no cycles, multiple edges or loops. So you can see over here in our graph 3, so you guys should know what a loop is. It's when you go back to the same thing. But a cycle means like it's connected in and then you come back to the same vertex like that. And then obviously multiple edges is like when you've got two paths going between two vertices or more so. So what a tree, so if we remember what connected means, so a connected graph meant that you could get to any other vertex either directly or indirectly, okay? That's what connected means. So you wouldn't have any isolated. So a tree is going to be all connected, but just not have any of these loops. So you've got down here, graph 1 is a tree. So you can see it sort of branches out, but they never like cycle round. And we can see here, and then there's another little rule. If you have a tree that has n vertices, so if it had 8 vertices, it will have 8 minus 1 edges. Okay, so let's have a look at our examples down here. If you look here, this graph, let's see how many vertices does it have. If we count, so 1, 2, 3, 4, 5, 6, 7. So the vertices is 7, so n would equal 7. So if you would have 7 minus 1 edges, which means it would have 6 edges. Did I count the vertices right? 1, 2, 3. It's 8. So 8. So it'd be 8 minus 1. So we should see 7 edges. So let's have a look if we do. So I'll just highlight them. So we've got 1, 2, 3, 4, 5, 6, 7. Yep, that works. So if we look at the next one, let's see how many vertices do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got n would equal 11. So n minus 1 edges. So 11 minus 1 equals 10. So we should see 10 edges there. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yep, and that proved to be right. So the next thing we want to look at is what a particular type of tree, which is a spanning tree. So a spanning tree is when you create a tree, but it connects to every vertex in that graph. So if you look at graph 1, they have found a spanning tree, and they've shown you what it is with the graph 2. So if you have a look, what they did is they got out to every vertex via like an edge, and there's no loops or connecting, and so there's a spanning tree because we get to every vertex. And then can be more than one option. So then they gave a second option here. So you could see that in the graph there. So they went along this way, they spanned out that way, and then they didn't have this bit, but they had out here. Yeah, so I've got to every vertex without connecting up. All right, so that's what a spanning tree is. So let's hear. It has a look and it says find 2 spanning trees. So first of all, we're going to highlight it and then we'll write it out. So I'm going to start at A and I'm going to go, it's quite fine for me to do that. That's a spanning tree. I haven't connected up. So 2 spanning trees. So I'll redraw it. So I'll say my first one, A, E to D to C out to B. There's my first one. And now I'll try to find another one, something different. So as long as I don't connect up or cycle around, so I might go down this time, might reach out like that. And there's my second one. I might do that. You might have a different thing. It's okay. We'll just check that yours is not looping or not cycling, or you haven't got multiple edges. Yep. Okay, sorry, A. So there is my second type of spanning tree. So we've gone to every vertex, yeah? You've got to make sure that's what spanning means. You've got to get out to every vertex. So the next thing we're going to look at is minimum spanning tree. So we saw graphs that had a weight on it, which means we're starting to see graphs that have numbers on the edges. So what we say a minimum spanning tree is a tree that gets out to all the vertices with the minimum distance or the minimum weight, okay? So if you look here, they've had a look at this graph, and they've said that if you go out that way and out that way and out this way, that would be the minimum connections, like, so that's the smallest amount you could get in a spanning tree. So what they've added up those numbers, and you can see down here, and so the minimum spanning tree distance or whatever it was is 189. Now this is, you can just do it by inspection, which is probably what you just did there, you're having a look, or there is an algorithm that can help you find the minimum spanning tree. So this Prim's algorithm, so just don't panic, an algorithm is just a set of steps that you keep repeating until you've got the outcome that you need. Okay, so the instructions are there, but I'm going to show you on an example to help you, because it's pretty self-explanatory. It's pretty easy to follow once you see it. Okay, so with a Prim's algorithm, you pick any vertex, because you know you have to reach out to every vertex anyway, so you pick any one. So I'm just going to pick A. Then what you do is you look for the smallest edge coming out of A. What's the smallest edge coming out of A? 2. The 2. Good. So you connect that one up. Now you've got A and B highlighted. Out of those two, which one is the smallest edge coming out? And remember, we don't want to loop back or we don't want to cycle back, but which one is the smallest? They're coming out of B or A? I would say 5. Yes? So 5 would be the smallest. It was out of, this was the choices. I had 8, 5, 6 or 6, yeah? So I picked 5. Okay, now I've got to look at all of them. So I'm still looking at my 3 vertices. So what's coming out of them? What's the smallest without creating a cycle? You know, I don't want to go backwards onto another vertex. 3. Yep, good. So 3 would be the next one. Now look at all of them. What's the smallest coming out? 6. No. 5. So you got 5. And then what's the next one? 2. So have we gone to every vertex? Yeah. Yep. So now what you can do, it says write down the total weight of the minimum spanning tree. So we're going to add up all those numbers. So it'll be 2 plus 5 plus 3 plus 5 plus 2, which is 17. Okay. Okay, so let's give this one a go. We're going to use the Prims again. So I'm just starting at A. You can start at any one, it doesn't matter, but I'm just going to start at A. So what's the smallest one coming out of A? 2. Now out of A and B, what's the smallest? 1. Good. Now out of A, B and E, what's the smallest?
3.
Yep. Now when there's actually 2 3s, so it doesn't matter, you just pick one, that's fine, as long as you're not looping back. Now out of all of those A, B, C and E, what's the smallest? 3 again. Now is that okay? Have I looped back? Yeah. It's fine, isn't it? It's still a branch, isn't it? We haven't connected it, so that's okay. Now, oh actually it wasn't E, this one was, we haven't looped. E was actually the smallest, so we should have done that one first. Anyway, that's okay. Now, which one's the smallest coming out of all of them? 2. And what about the next one? 4. Good. And what about the next one? 2. So you haven't connected in any way. So what you're going to do now is calculate the length. So just go and circle all your numbers that you have highlighted. And then as you add them up, I suggest you cross them out because it'll make so you don't double count them. So I'll go 2 plus 1 plus 3 plus 3 plus 2 plus 4 plus 2 plus 2. Okay, and then you add that up. So that's 3, 6, 9, 11, 15, 17, 19 is the minimum length, spanning length.